On this problem, a couple problems, we have to use Rolle's theorem. Remember that Rolle's theorem says if you have a function that, well, if f is continuous on the entire interval and f is differentiable on the open interval, and then also Rolle's theorem adds the stipulation that mean value doesn't have, f of a has to equal f of b. So the first thing we should do is make sure all three of these things apply to the function we're given. Now f of theta is secant. That's the same as reciprocal cosine. We could potentially have an undefined value because cosine can equal 0, which would make this denominator 0. Where does cosine equal 0? That's at the north pole of the unit circle and the south pole of the unit circle. So at pi over 2 and at 3 pi over 2. And then the next question is, are either of these on this interval? Well, 3 pi over 4 is over here. 5 pi over 4 is down here. The issues would be at the north and the south. So like, we're good. We're good to go as far as continuity, as far as differentiability goes. The only other question is, does plugging 3 pi over 4 into the function give you the same thing as plugging in 5 pi over 4? Well, cosine of 3 pi over 4, that's in the second quadrant, that would give you a negative square root 2 over 2. And cosine at 5 pi over 4 would give you also a negative square root 2 over 2. So yes, the answer is yes, we can apply Rolle's theorem. Then they want you to figure out where, what the c value is. So the c value is, if you have all this being true, somewhere f prime on that interval, f prime of c they call it, has to equal 0. So we're just going to set the derivative of this thing equal to 0. So derivative secant is secant tangent. We have to make that equal 0. So that'll happen if secant equals 0 or if tangent equals 0, because these are factors. We can use zero product property. We can say either the first factor has to be 0 or the second factor has to be 0. Secant will never be 0 because secant is 1 over cosine. And if you have a fraction with a top of 1, that fraction can never equal 0. But tangent can equal 0. Tangent equals 0 right over here, because tangent is sine over cosine. Tangent sine over cosine, so if the sine is 0, this whole fraction will be 0. And that happens, I'll call it c because that's what they're looking for. That happens when theta is pi, and pi is on this interval. For number 13, they're talking about the function 1 over x. Well, I already know that's not going to be continuous when x is 0. But 0 is not on this interval, so maybe we'll be okay. It'll also be differentiable everywhere except where x is 0, but that's not on this interval. So then the next question is, does f of 1/2 equal f of 1/4? And I don't have a good feeling that it will. 1 over x with a half plugged in is 1 over 1/2. That's 2, the reciprocal of 1/2. 1 over 1/4 would give you 4. That's the reciprocal of 1/4. F of a is not equal to f of b, so our answer is no. We can't use Rolle's theorem, and the reason is the endpoints are not the same value when you plug them in.